As meteorologists, we use radars every day to help us predict the forecast. They're perfect for picking up rain, thunderstorms, hail, tornadoes, and even more weather phenomena. But would you believe me if I told you that they can pick up a lot more than just weather-related things? This photo right here is what all National Weather Service Doppler radars do look like. A radar, or otherwise called a Doppler radar, is an instrument that sends pulses of electromagnetic energy into the atmosphere in different directions to find precipitation and determine its motion intensity, and as well as identify the precipitation type as rain, snow, or hail as defined by the weather company. This is kind of an easy way to show how a radar sends the electromagnetic waves. It shoots them towards a direction, and this ball is supposed to signify what it is picking up, which could be rain or a storm, and this waves shoots to this said object and then goes back to the radar to give them the data that they need. Although these electromagnetic waves can pick up more than weather-related things, as it is moving, things get in its way or it doesn't always know what it's picking up. It's not specifically looking for something weather-related. It is just trying to pick something up in the atmosphere, and things can get in the way like birds or buildings, etc. Some examples of these things that radars can pick up that are quote-unquote problems. They're not problems. A radar can't tell what exactly it's picking up. It's just doing its job. Is ground clutter, beam blockage, and anomalous propagation. And those are just to name a few of the things that radars can pick up. Beam blocking is when there is something blocking the radar from being able to detect weather conditions in the atmosphere. As you can see behind me, this little stripe of clear, there's not red or green, this is the beam being blocked from being able to send all of this to it. And this is actually trees preventing this from happening. This is a picture of the actual radar where this problem is occurring. It doesn't look like those trees are very tall from the height of this picture, but they are the reason for why we cannot detect certain things in that specific area. This is a problem though because the trees show that there is nothing there in the lower levels of the atmosphere, which is not always the case. This is how we tell severe weather conditions and storm conditions, and without this, it can lead to a dangerous situation because we cannot see what's physically going on in that area. This station is in Charlotte, North Carolina, and because of this, the National Weather Service is currently, I'm not 100% sure if they have done it yet, they are relocating this station to prevent any future dangerous situations if they cannot see anything because of the trees blocking the electromagnetic waves to detect anything in the lower levels of the atmosphere. The next issue I'm going to be talking about is anomalous propagation. That is when a radar returns data from the atmosphere that doesn't represent precipitation or any other meteorological object. And this is referred to as a false echo. Right here, you can see this line of purple. It looks like rain, but it is not. It is the smoke of a fire from a train derailment in Ohio. This occurred on February 3rd, 2023 at 8:55 p.m. Due to the cargo that the train was carrying, which was mainly vinyl chloride, which is highly flammable, when it was being carried, it fell and derailed from the tracks. It caused the train to burst into flames, and the smoke was detected on the Pittsburgh, Pennsylvania National Weather Service radar. Due to the cargo that the train was carrying, it was carrying vinyl chloride, which is highly flammable. So when the train derailed, it burst into flames, and you can see how high this black smoke was. That is what caused the Pittsburgh, Pennsylvania radar to pick it up and make it look like rain. I'll show it here again. This is another photo I have of it. You can see the smoke traveling. It looks like a rain cloud, but it is not. The last case I'm going to be talking about is ground clutter. Ground clutter is an unwanted signal that occurs when a radar's waves bounces off an object in the ground near the radar. This can be buildings, birds, trees, etc. An example of this would be during a severe weather event in Atlanta, Georgia on March 2nd, 2021. This is the radar behind me. You can see the severe weather warnings as well as a tornado warning. This was taken at approximately 7:58 p.m. But as you can see, not everything on the radar is rain. The random spots that are around the storm, the little ones, that can be ground clutter, and that can be very deceiving when it comes to predicting severe weather. Because it could be mistaken as rain rather than just clutter near the ground, It can be very dangerous, and in this day in particular, ground clutter could have caused many issues because this day an EF4 tornado was recorded and passed through Newman, Georgia. Here's a picture of that tornado that occurred on that day, and as a non-meteorologist, it's kind of easy to tell that things like this can make it very hard to predict weather and to keep everybody safe, because not all the time is it something that's weather related that is being picked up on the radar. Radars are key for doing our job in predicting forecasts, and as the days go on, radars are always improving to prevent things like this from getting worse and to improve these quote-unquote problems.